All right, last one for this week. So we're going to talk about all tangents today. So we talked about secants and tangents when they intersect with a circle and with each other. And we talked about when chords intersect with each other and a circle. So we're going to talk about secants and tangents today. So we're still doing the same standard as before. And today we're going to find out how to find the missing portions of a line tangent to a circle. So quick review. If I draw a tangent, that's my circumference of my circle. There's my point of tangency, and there's my tangent line. So a tangent is when a line intersects with a circle in only one spot. That's my tangency. Okay, we're going to talk about perimeter means to add up the outside, and the perimeter for a circle is the circumference. And we'll talk about that in another lesson. And we're going to use Pythagorean's theorem today. A squared plus b squared equals c squared. And we use this only with the right triangle, where the A and B are legs and the C is the part across from the right angle. Okay? So that's a quick review on vocab. Okay, so let's do a quick way to look at tangents in a circle. So what happens if I have two tangents that intersect with each other? So I'm going to draw 2 points of tangency. And I'm going to make these two intersect with each other. Alright, and here's where the two intersect. There is a rule that tells us that when I have two tangents that intersect each other from a point on the circle, these two sides are equal to each other. So if I call this A and B, so from the point of tangency to the point of intersection, I'm going to call that A, and from the point of tangency to this point of intersection, I'm going to call that B. So this tells me that A equals B. Okay? And we also know, well, I'll come back to that later. So now let's look at right triangles in the circle. So here's my circumference. And I am going to look at this here. So I'm going to draw a chord. And then I'm going to draw my right triangle. Or I'm going to draw, well, let me do it like this. I'm going to draw a chord first. So let's draw the chord. I'm going to draw a chord. And then I'm going to draw right here. I'm going to make this the center of my circle. I'm going to draw a radius straight through here. Okay? Let me put it in red. This line here that goes through the center of the circle and intersects with this black chord is a perpendicular bisector. And you can keep it going if you would like. It's a perpendicular bisector. So when it does that, that means we have a right angled form right here. And by definition of a perpendicular bisector, it is a line that crosses a segment at a 90-degree angle. And it also splits this segment in half. Okay? And if you want to be more detailed, you can go ahead and label these sides. You can call this A, you can call this B, you can call your circle as circle O, or whatever you want to name your circle. That's the center of the circle. And this point right here, we can call it P. That's our midpoint. Oh, we can call it P. It's our midpoint. I'm going to draw that midpoint so you'll know. And that red line is a perpendicular bisector. And from the center of the circle to this point right here on the circle is called the radius. From the center of the circle to this point down here is called the radius. And this is not drawn to scale, guys. And that's something you have to understand in geometry. Nothing's really drawn to scale unless they have to tell you exactly what everything is. You can't make any assumptions. Okay, so if you look at this on our sides here, we can draw a right triangle. And if we need to find missing parts, then we can use Pythagorean's theorem. We know this side is going to equal this side because that's by definition of a radius. And because we know that, oh no, I'm sorry, that's not going to equal that side because that is not a radius. That's not coming from the center. We know that these two sides equal each other, so that's A and A here. And this is some measurement we don't know. We can call that B. And this out here would be your C. So that's the general understanding of this. I'll give you more details as we work on the problems. So here, this says to solve for x. First thing I got to do is investigate what kind of segments or lines that we have. And these are segments here. You can extend them to see the line part if you want to. That is perfectly your preference. So here, I'm noticing I have a point of tangency here and a point of tangency here. And these two are the points of tangency, and they're coming from our radius. So the rule tells me that I have two tangent lines that intersect. Then that means this side should equal this side. These two sides should equal. So A should equal B when I have two tangents. So here I'm going to do 5x minus 6 should equal 3x plus 12. So I'm going to go through here and draw my little dotted line going down. And the rule says that I want the variables on the left and the constants on the right. And if I cross over this golden line, I change the signs. So I get 5x equals 3x plus 18 and minus 3x here. 2x equals 18. So I have my variables on the left and my constant on the right. Now I can go through and divide by the coefficient in front of x. So x here should equal 9. And you can always go through, make sure you're right by substituting this back in, and both sides should equal each other. Okay, so go through, solve the rest of these problems. And now let's get to this one. Let's go to this one. This question tells us to find the perimeter. So first thing I need to know what perimeter means. Perimeter means to add up all the sides, and to help you to remember that, you look at, there's the word rim inside of there. So I am going to go and investigate each one of my lines to see what I have going on here. If I start here, I notice this is a point of tangency, and over here is a point of tangency. Well, I know a little rule. So if I know that I have two tangent lines and these two are points of tangencies on this circle, then the rule tells me that if this is 4.9, then so is this 4.9. All right, so I'm going to go investigate the rest of these. I see this, that's another point of tangency, and this is another point of tangency. So if this piece right here is 9, then this side over here is also 9. So I got that little piece. If you look at this, hold on. All right, so I have another point of tangency here, and I have another point of tangency here. Well, I don't know what any of these equal, not these two purple ones, but it did tell me that this whole thing here was 12.9. And I know from here to here is 9. So if I take my calculator and I do 12.9 minus 9 should equal 3.9. So that means this little piece right here is 3.9. 3.9. So now that I figured out this piece, and I know these two should be the same because they're both coming from this point of tangency here. So this is 3.9. And if I go and look on the other side, I'm going to do it in green. Then I have another point of tangency here from here, and another one from here to here. So these two should be the same. So if that side is 7.4, then so is this side, 7.4. Now I can answer the question. So I did my investigation on this problem. Now I need to go back and answer the question. What is the perimeter? Perimeter means to add up all the sides. So you can do this old school way. Go 9 plus 9 plus 4.9 plus 4.9 plus 3.9 plus 3.9 plus 7.4 plus 7.4, which would equal, let's grab that calculator and let's see. 9 plus 9 plus 4.9 plus 4.9 plus 3.9 plus 3.9 plus 7.4 plus 7.4 should equal 50.4. And we don't have any units here, so you can say 50.4 units. Now there's a quicker way you can do this too. How many 9s you have? We have 2, so I'm going to say 2 times 9 plus 2 times 4.9 plus 2 times 3.9 plus 2 times 7.4. And you can put that in your calculator and you should get the same exact thing. So either way you want to look at it, you'll get the same answer. Alright, so work through the rest of these problems and then get here with me and we'll talk once you finish those. Okay, so this problem now is telling me to solve for x. So I need to do some investigation before I even look at to try to solve this problem. So I see here that I have a radius, this radius right here, from the center to the circumference. And I notice that I have a right angle right here. So this is telling me that this is a perpendicular bisector. So I know that if this side is 17.7, then so is this side going to be 17.7. So right here, this is 17.7. And if I want to find this radius right here, then I need to do Pythagorean's theorem. So I'm going to use, since this is a right triangle, I'm going to use Pythagorean's theorem. A squared plus b squared should equal c squared. Alrighty, so you can call any side you want to as A and B. Just make sure you get C right. So A is 9.4 squared. B is 17.7 squared. And C is x squared. So I'm going to use my calculator to help me out with this. So 9 point, well, make sure you put this in parentheses. Anytime you put something into an equation, always put it in parentheses. So this is 88.36 plus equals x squared. Now you're going to add these two together. So 401.65 equals x squared. And to find x, we take the square root. The square root of both sides. So you get x equals, so I'm going to push second squared here. I just told the calculator to type that answer in. And then we get x equals 20.04. All right. Now, here's another way you could have looked at this. If you notice here, this is the radius. So I'm going to use my math and what I know from the picture to double check myself. So I found my radius to be 20.04. And if I look here, from here to here with the green line should be exactly the same as the red line, because that's just the definition of a radius in a circle. So if I add these two together, 10.6 plus 9.4 should equal, let's check the calculator and see if we get the same exact answer. So 10.6 plus 9.4, and that's about the same, 20. And it doesn't have the 0.04 part. Our calculator had more numbers to deal with, so the answer is a little bit more accurate than just looking at the rounded answers here. So you get the same exact answer. That was for us. That was lucky for us on that problem. It might not always show up that way, so you need to make sure you understand to investigate your problem and then go and look at what process you need to use to help you get the answer. And then if there are other pieces in there that you know to be true, use them to double check to make sure you're right. Okay, so go ahead and finish up the rest of these problems. And see you in class. Bye, guys.